So this is episode 4 of Signals and Noise, Manufacturing with Dovient. Very excited to have Shashank here with us today. This is the first of a 2-episode arc specific to manufacturing. And here's kind of how the episodes will build out in this manufacturing arc. So this first episode is more about understanding the environment, the problem, what makes manufacturing so hard to plan, and what happens before AI and what changes once you have AI in a manufacturing environment, which again is why I'm so excited to have Shashank join us, and we can talk more about Dovient. And then episode 5, we're going to go a little bit deeper into capacity decisions, lead time management, inventory positioning, working capital trade-offs, and how hard optimization problems are and how that compounds once you get the foundation right. So today's all about that, the foundation. So without further ado, let me introduce the team we have today. So we have Shashank with Dovient. Shashank works at the intersection of AI and manufacturing operations. He's seen both ends. Excited to hear a little bit more about his background and his perspective on this. Genuinely glad to have you here. Really been looking forward to these episodes. Harsha, thank you for being back again. Harsha's our lead AR architect. He's here all season. I believe, Harsha, you were sick last episode, right?
Yeah, but I'm better now.
There we go. Harsha's feeling better. His voice is coming through clear. So yeah, Harsha's going to help us dive into more of the technical aspects. And Varun, who was with us for the other episodes, is actually traveling, working on his executive MBA. So we will not have Varun today. So before we dive into the questions, just kind of remind everyone the format. We'll ask a few questions and then we'll have a roundtable at the end. Before we do that, Shashank, do you want to give us a little bit about yourself, a little intro, background? Why Dovient? What brought you here?
Definitely, Sean. Yeah, very good morning, good evening, or good night from where you are watching this show. So myself, Shashank, I'm a serial entrepreneur. So I started a few companies, before starting Dovient. So, um, so we visited, quite a few manufacturing industries and tried to identify the hard problems that are on the shop floor, especially. And we built a maintenance management system, intelligent maintenance management system, powered with AI agents. So I'm very excited to join. So that is very meaningful, and I really believe the conversation is going to be really useful for the audience who are seeing this.
Awesome. Yeah. And then since we don't have Varun, normally I would ask him this question, but we have you here. And I know a lot of the conversations between Astra and Dovient predated me joining Astra. So maybe you could talk a little bit too about the relationship between Astra and Dovient and kind of our partnership and how that looks.
Yeah, definitely. So we are focused on building the product, building the platform. So which Astra would be a great partner for implementing and taking it to the market. We would love to have Astra as an implementation partner for this product, so who would help us reach especially the US market. So we're very keen to get to the advanced manufacturing companies. So Astra brings, I think, the data expertise and the solution expertise, where the engineering talent at Astra would definitely help us frame the solution for the customer with the product what we have. So it's I think a good combination, for someone looking at implementing Dovient in the shop floor.
Awesome. Thank you. Yeah, I know as Astra, we've had some experience with manufacturing organizations, but we're definitely not what I would consider a subject matter expert like yourself. So yeah, like you said, I think we make a really good team together in terms of helping the U.S. market implement Dovient. And then Harsha, maybe you could talk about a little bit about your relationship with Dovient, and then how that transpired to now your relationship with Astra.
Oh, yeah, I have a long relationship with Dovient, Sean. So I was initially working with Shashank to implement some of the AI agents uh, for Dovient, and that's how I got in touch with Varun as well. Like because Shashank, Varun, I think have a common connect. Uh, and Yeah, now I think I'm more obviously focused on Astra and stuff like that, but I still keep working with Dovient once in a while for the agents work.
Yeah, so Shashank, thank you for helping us find Harsha. He's been a really great resource on our side as it relates to everything we're doing with decision intelligence. All right, cool. So that's a little bit more about the team and the relationship between Dovient and Astra. So let's get started. I think kind of the hard hitting question first. So like manufacturing. I would say, from my perspective, AI in manufacturing, there's probably a lot of concern about that. I mean, just my own experience with manufacturing, a lot of times the intersection between operational technology and information technology, a lot of times those environments operate pretty separately by design from a security standpoint. Um, so now that we have, all of this great capability with AI and being able to interpret a lot of this telemetry data that's coming from machines, uh, marrying that up from the OT environment with the IT environment. What does manufacturing look like now before AI and after AI?
Yes. Yeah, very interesting question, Sean. So manufacturing is one industry, I think, like, which some people say that, the AI hasn't penetrated as much as other industries. So we have a lot of AI being used in retail, sales, marketing. So those are the prime areas where, the agents world came in. So manufacturing is a bit slow to react to the AI world, rightly. So because in the manufacturing, I think you had to get it right the first time. So there are only few chances of making mistakes on the shop floor. The mistakes are expensive, and the shop floor teams itself has to invest lot of time and effort, to focus on getting AI implemented on the shop floor and be production. I mean, using it in the production, not just like a pilot, right? So just to answer your question, before AI and after AI, so there are only few case studies because the AI is still very new. I mean, it's just 2.5 years, 3 years into the game. If you look at a manufacturing company, the technology they adopt is more long term, more strategic, and it takes 4 years, 5 years, something to establish really solid on the shop floor. So plants, may have ERP systems, may have reports, may have dashboards, may have all these tools before the AI, right? But if you look at what is happening on the shop floor today, so there is delayed visibility. There is operational variability is there. So operations is not as smooth as everyone expects it to be. So there are always surprises on the shop floor, and when there is a surprise on the shop floor, so there is a delayed visibility on the data, and the decisions that they take on the shop floor is also delayed. With AI, so we accelerate the decision making power of the shop floor managers, of the staff that are there on the shop floor, which would improve the efficiency of the shop floor operations massively. So I can take a few examples.
Yeah, yes,
you know
please.
Definitely, yeah. So if you see just a normal planning that happens on the shop floor, they get the order, right? So then they go there, look around, and they might have some system where they suppose they open an Excel sheet and figure out what is busy, what is not. So then they had to interact with the safety team, what to start, when to start, and is is a batch that was done previously BQA'd, so then QC comes into picture. So all of this coordination right now is happening still manually, even though they have all these systems. So when we bring AI into the picture, so AI helps them take these decisions much faster with the historical data, because a lot of these things is repetition. I mean, it's not the first time you encounter a similar problem. So we feed all the history into the system and arrive at the intelligence much quicker, much faster. So to just in a nutshell, the teams react can react early, planning can become much more adaptive and escalations reduce and leaders gain much more visibility.
Yeah, no, thank you. I think you hit on a couple really interesting points there. I think kind of the first one around manufacturing, taking their time to really make a decision on a technology investment. I think there's a couple things there I just want to comment on. Like, a lot of the AI use cases I see in production today are kind of the lower risk if you get it wrong, right? Like customer support agents, chat bots. Like, if someone asks a question and it's not necessarily right, it's like, oh, maybe they'll just call instead, right? But if you get something wrong on the shop floor and all of a sudden you got to run for a part that you didn't need or wasn't asked for, then yeah, that's a huge hit to your bottom line, right? So I think uh, to the from the perspective of like the adoption should be slower by design because the risks are higher. And then also too, I think your comment around the way they invest in technology. I mean, my own personal experience working with a lot of these OT devices is that they still use like Modbus as a protocol in terms
Right.
of how they're delivering data, and that's something that was developed in the 70s, right? And it's still used today. And like a lot of these machines that are running on shop floors might also be from the 70s because these machines are very very expensive, and as long as you maintain them, why would you replace them, right? Because you got to get maximum ROI out of a very expensive machine. And like cars, a lot of things were built better in the 70s in a lot of cases as well. So you want to try to get maximum investment there. So yeah, it's a very interesting vertical, I would say. But I think like you've mentioned with the examples you gave, the value you can get when done right, and using something like Dovient to help you build confidence that it is production ready, will really help enable the team move from this manual planning, root cause analysis, whatever it may be, into a more streamlined and efficient way of doing things. So no, thank you, Shashank. I think you teed it up really well. So Harsha, um, we gotta talk about the technology a little bit more here. So let's dive deeper into why is this such a complex problem from a signals perspective, and what are the different signals or feeds that Dovient is taking in order to help de-risk and make informed decisions?
Yeah, I think Shashank will be better at this, Sean, but I can start because Shashank is also a very technical guy. So he's not just a
Oh, I
domain
know.
person.
Yeah.
Yeah. So I can start maybe, but I think I want Shashank to add in later on. But yeah, like on the point that Shashank was telling earlier, right? I just wanted to tie up because we had I think we had a call with one of the clients when I was working with Dovient in, I think this was last year, and it was very interesting. We did a lot of good work on AI using a very minimal data that they had. We built some agents. We were showing how you can do predictive maintenance and things like that. And they saw all the demo, and the only capability they liked was voice-based interaction. So they didn't like it. So, so I think their entire point was that, oh, all of this we already know. The only difference I see is basically a voice, like having a voice capability to automate some of the work. Like instead of typing it out, can I just use voice? I think they got like very much stuck onto that point that okay, like yeah, I think we went. I think there was a pilot also done on that. So yeah, it's pretty interesting. But anyways, like I think like uh, uh, like like I was saying, just to connect back to that point as well, the data, like the complexity comes not just from the process, it also comes from data, right? So let's say uh, a lot of thing that happens on the floor is never known to a system, right? So if there is a, let's take a breakdown scenario that is happening on the shop floor, right? So you can capture an event that the breakdown has happened. You can capture some signals associated with the breakdown, but you never know what is the root cause unless someone types it or things like that, right? You can build predictive maintenance models, you can build root cause analysis models and things like that, but still they will not be very, very accurate. And at the end of the day, the person who is actually doing the fix there knows obviously more than what the system can capture. It's also because the system is not like you guys said, right? It's these are all old. These are also like legacy systems. They don't obviously stream data on. They don't stream sensor data at real time, right? So that challenge always exists. That is the first challenge, and I think the second challenge is basically causality. Like basic. And so if you have to link two events, that let's say something something happened in the shop floor, or uh, some unusual anomaly has been observed by someone in the shop floor, and that may be led to a issue 3 or 4 months down the line, right? These things you can retrospectively analyze and tell that, okay, someone identified a trigger for this 3 4 months back, but it was basically not it was not basically digitized, and it was not really turned into an action that you have to fix something, right? And um, so these type of signals, if they are not even available, AI cannot also predict everything, right? So it's kind of, you have to work with you are working with, let's say if there is 100% data on the floor, you're just working with 20% data always, because the remaining 80% is in the head of the planner. And also the whatever 25% data you have is basically highly connected data. Like you have some event triggering something else, and then that is leading to a failure at somewhere in the factory. Now you have to basically build this lineage. It's not a direct lineage, right? You have to basically make assumptions about it, build indirect this thing, indirect connections and things like that. And third is like whatever data is also available is also kind of very unstructured. So what like it's all notes, right? So people write notes, they just upload the notes, or like they have these systems where they can just capture notes and things like that, right? So making these observations from the notes is also very difficult, and people have these shift reports. So at the end of the shift, they keep writing what did they observe, what were the issues, and things like this. And if we want to solve this problem, the most important part is kind of digitizing all this unstructured data, like a lot of unstructured data, digitizing it, and more importantly, converting that unstructured data into structured, like basically connecting that back to an event. So I know someone has written a log about, let's say, an anomaly that has happened, and basically an event and a system failure got triggered 3 days down the line in the same machine. So you should be able to link these two events, and this is where graphs and all of this come in. And that is one of the things that I think in Dovient at least we tried to do a lot of it, like basically building knowledge graphs, connecting events, connecting mainly structured and unstructured events coming from logs, and structured events coming from this thing. And there was also like other things like recording, uh, giving planets capability to record whatever they see on the fly through a simple interface, right? So that they don't need to feel that Dovient is like a, what do you say? They don't need to feel that it's like a big form that I have to fill. It's basically just a simple chatbot that you can basically input your data to, and it will continuously keep capturing your observations and uh, making it structured. So at least the idea is whatever you have, at least if you have 20%, can you make sense out of the 20%, and you push that 20% to at least 40%, so that you have a broader information uh, information that you can work with. That's essentially, I think, what we what was tried a lot in Dovient. But maybe, yeah, Shashank, I think you would be the best person for this.
Yeah, anything you want to add?
Yeah. So the signals context, I mean, so context is what was not possible earlier. If we just, on continue to what is before AI and after AI. So before AI, we have a signal, we have a data point, but the context that comes with the context engineering, now these LLMs and, you can feed context onto the signals and make more meaning out of those signals. So this is very new. A systems engineer earlier working with all these tools. For example, there is a IoT engineer who
Mm.
is familiar with all the IoT signals coming from these machines and make meaning out of it, right? He might have a good ML model, but does he have the context? Does he know it's a legacy mission? Does he has knowledge regarding the mission that sits that you can pass as a context to that intelligent system, right? LLM, or it's a small language model that you built on your own. So whatever, that part makes it very interesting now.
Yeah. I just want to add one thing. I think in manufacturing, one thing like we said is like if there is a false negative, that means let's say you haven't caught an issue, let's say, and you haven't predict or you haven't solved an issue on time. That's a problem. But a false positive is also a problem. Like if you basically say that, so if you basically predict an issue, but that issue didn't actually happen, right? You would have stopped the line to fix that, to do a predictive maintenance task, right? And that is basically causing a downtime in your downtime in your plan. And even though what happens is that even though it might not be a negative, like it might not be a very big um, like it might not be a very big issue, but you will still lose production, right? Because you are basically causing a downtime to do production. So that's why a lot of people are also skeptical. Like what Shashank was saying, uh, if I just look at a signal and try to predict based on the signal, it will never give you the full picture. Like all of this unstructured data that sits, the context of what is happening, what has happened, did anyone find a similar issue, and is this even a issue that someone needs to care about? A lot of this sits in like people's heads or people's logs, right? So that's where I think being able to extract all of that context and then being able to fuse it with a traditional machine learning type of algorithms becomes very important.
Yeah, no, I think you hit on a lot of the points that I personally see as very interesting with Dovient and as a value add where getting the information out of people's heads, right? Like that tribal knowledge
Yeah.
transfer and being able to have the technicians record voice notes on the mobile application as they're doing a fix, evaluating a machine, whatever it may be, or having technicians have the ability of when they're doing a fix or they're doing a routine maintenance to actually record a video of them doing it so that if other people during a shift when something goes wrong and that needs to happen and that person isn't there, they have a reference point with the video outside of just the manual and what the manual says how to do it. So if there's something unique about how it's actually done in this specific manufacturing org, or things they may have changed over time that differ from the manual, they have that firsthand look and view of someone else doing it. So I think those are two really interesting aspects of like being able to do that tribal knowledge transfer of the actual work and maintenance being done on the systems. And I'm also glad, Harsha, you brought up the concept of the graph and trying to connect all these things. And I think maybe that customer you had highlighted earlier who was like really into just the voice component, maybe they weren't seeing the bigger picture too of like, oh, we already have all this, but it lives in 5 different systems. What if you had all this in the same place and the ability to digitize your notes as they happen in real time, and then the graph connects all of that, which then makes the decisions or the flags of alerts more informed because it has that context. Because like as you had both discussed, the signal is only, when it's evaluated by an LLM, it's only as good as the context you give it. So when you have more context from all the associated things going on, you get a better result. So I think that's something that Dovient does really well, and something I've found very interesting about it. Okay, cool. So we've talked a little bit about before and after AI. We've talked about a little bit of the technical layer. Maybe we can go into a little bit more about what does like planning confidence look like with and without Dovient. Like what does Dovient provide to the planning side of a manufacturing shop floor once they've established kind of what we've talked about, where they have these interconnected systems now, they've started to transfer that tribal knowledge. What does this do now as an outcome for an organization?
Okay, so it's a bit technical. So
Yeah,
try
go
to give
for
a
it.
picture on. I would try to give a picture on how large manufacturing organizations target this and how Dovient fits in there. So if you see a fairly large manufacturing organization, so there are reliability engineering teams who do a failure mode effect analysis on all the systems. So they call it FMEA analysis. We have process FMEA, we have maintenance FMEA. So I would just to speak a little bit about maintenance FMEA. So you have all the shop floor missions. So you do a failure mode effect analysis on all the missions. Then from that failure mode effect analysis, so you identify um, the components which could fail, so that you can plan the maintenance for all these components of the missions. So you derive plans from your failure mode effect analysis, and you publish schedules on a typical manufacturing company today I'm speaking about, which hasn't adopted AI yet. So you derive schedules. The schedules are probably static, that, hey, look, like, on every month this component may fail. So you are running this many cycles. So just go repair it, replace it, find a component, that you can replace, right? So that's how it works. So, but now, with Dovient, with a platform like Dovient, all of this becomes very dynamic. You can see the variability in the failure mode effect analysis live. So your failure mode effect analysis may think a component could fail in a month, but while it's actually failing in every 3 weeks. So you reduce the time. So you push the plans accordingly, and the schedule also you adjust it. So there is under maintenance, over maintenance. Both of them are problems. If you over maintain, you are unnecessarily losing your production time. So that is costing your organization money. So if you're under maintaining, then that also is a problem. So you're ending up in more failures. So the failure mode effect analysis variability is what we manage through our agents, and which reflects in the plans, and then, it affects the schedules. So the planning becomes, much more dynamic. It's not static, and it doesn't always require a lot of manual efforts. So we push recommendations to the right people at the right time, so that they can adjust their plans and react much more effectively, eventually saving cost for the shop floor teams.
And the cost that save is kind of twofold, right? It's production, so increased production output, and then also to doing maintenance when you need it, not just this probably fails around this time, so let's just go ahead and swap it. So that there's
Absolutely.
probably a little bit
Absolutely.
on the parts, and then also the
Yeah,
technician's time. Okay, great. Yeah, no,
absolutely. And the most important part you mentioned about, right, losing production. So that, if you see even the largest organizations, when we visited on the shop floors, we are surprised to know that the maintenance manager still calls the production team to understand, whether something is busy, when they're supposed to do maintenance. All of this coordination, the nexus is really broken. There is chaos in the industry, right? On the shop floor, you see people running, people trying to plan, and there is delays, and all of this we can avoid. So we have a system, production system, that people can schedule in the Dovient system itself. We do have the production planning part, which is again intelligent, and we tie it up with the other activities, that goes on the shop floor.
yeah, I noticed in Dovient there's a really cool capability where you can actually put all of your technicians in there, their skill competencies in terms of like which machines they can work on and their schedule of work of when they work. So it does really have that intelligent routing of like this is who's available when and who can work on what and how does that relate to things that go down or when we're doing preventative maintenance, and then yeah, helping define that plan and hopefully reducing what you were describing of them calling the floor and being like, hey, when when can I get this guy in here to do this, right? So like yeah, trying to be a little bit more proactive instead of reactive in terms of how they utilize the downtime between machines and who it gets routed to. No, thank you for that, Shank. That was great. I think Harsha, just given that Shashank mentioned, the agents helping coordinate some of this stuff, and I know that's part of what you worked on. Maybe you could give us a little bit more insight into what all you kind of did with the agents as it related to either what Shashank was talking about or other parts you found interesting as you worked on Dovient.
Yeah, I think one of the things I found very interesting was basically these agents to do a lot of uh, a lot of these work around FMEA and both FMEA and fishbone, right? Like essentially, uh, think of like these as background agents. Essentially, what happens is manufacturing is all event driven, correct? So I said it's not like a fixed process. It's not something that you do weekly. or monthly or a schedule based. It's event driven. So something happens and then you have to basically react to it. Or obviously you have to react before something happens also. That's also an event that you have to react proactively. So what I found interesting essentially was this FMEA variants that Shashank was talking about. It's basically a background agent that keeps running and it consolidates data across multiple signals. So it looks at the breakdown data, it looks at historical maintenance data, work orders basically, preventive work orders or the maintenance jobs, breakdowns. It's basically looking at there's something called as Fugui that Shashank can talk about better, but it's basically a simple observations that people are capturing, and it's kind of building context on top of it, and it's planning automatic. It's creating plan automatically. So it's not like a planner has to go and then say that, hey, tell me where is the variance. But the agent will come to you and say, hey, I see a deviation here. Uh, why don't you kind of update your planning according to the deviation that I'm seeing, something like that, right? And other thing definitely is in terms of agents, uh, is essentially these. A lot of agents are also a little bit focused on root cause analysis, right? A smart way of doing root cause analysis. So for that, basically there was a lot of custom development done to kind of parse information. So in manufacturing, there is a lot of root cause analysis done using things like fishbone diagrams, for example. Right, fishbone diagrams is a good example of how root cause analysis or failure tracking is done. But obviously, fishbone diagrams exist on whiteboards. They exist on whiteboards or they exist on Excels and things like that. So we converted those to like in Dovient that was also converted to graph, right? It's a like that's a different structure of graph, like a directed acyclic graph. And basically there was agent navigating this graph to smartly identify how to do structured root cause analysis and things like that. And again, like this was also being continuously updated based on work orders. If you have new information or if you have new issues that are coming up, the wishbone gets updated very like on the fly, right? So this is also something that happens in the background without someone coming and telling that I have this issue, can you update the fishbone diagram based on this and things like that, right? So these two, I think, at least is something that I found very, very interesting on top of, I think the graph obviously we spoke about graph, knowledge graph of information that was developed. So agents sitting on top of that knowledge graph to navigate the complexity is something also that was very interesting, I think. And yeah, like tribal knowledge. I think tribal knowledge is a very big use case because, like you said, I think you said, Sean, like video, capturing videos, converting videos into smaller snippets, for example. Like, so obviously, even if I record a video, it might become a 1 hour, 2 hour video, right? And nobody goes through a 1 hour video nowadays. So can you basically break that down into 20-second, 30-second reel format videos and make it very, very specific? So think of like an agent that is sitting on top of all of this knowledge, whether it's videos or audio snippets, text, images, manuals, and then it's collating information saying, hey, this 30-second like this thing that was done by someone, and basically this part of the video especially, so it was a 1 hour long process that someone did, but this part of the video, which is just 20-30 seconds, might be the most relevant for you at this point, and you go through it and then basically you will know how to fix this issue or something like that. So I think this was also done through a troubleshooting type of an agent. So some of these I think I felt were very interesting. And there is also a lot of work around offline agents because a lot of these agents, obviously, when you use LLM, large language models, they need to be connected to the internet, right? You are basically putting them on a sandbox, like a GPU. You need a server that hosts these large language models. So you obviously you'll connect with them through a network, and then you will need to be online somehow. But in manufacturing, always that's not the case, right? That's a big challenge because when you're operating at real time, and obviously when you're in the floor, you will basically have to work with offline data. You will have to work with you'll have to work in an offline environment most of the times. So there were like a lot of smaller models, like much smaller models, 2 billion, 3 billion, 500 million models that were basically used for very, very specific tasks, like basically uh, like for example recording an anomaly. So if someone is recording an anomaly, converting that into structured form. So very, very specific task, very, very specific agent that works on a very, very small model that just takes the context and it converts it into structured information. So some of this was basically explored, and yeah, I think Shashank can add more. But this is some of the things that I found very interesting in the way in the way the
Yeah.
development was done. Yeah,
No, yeah. So you really like the quality engineering aspects of this. I think that's great. I know, especially here in the U.S., Motorola kind of coined the like Six Sigma type of framework as you approach quality engineering. I know a lot of times, when I
yeah,
was an engineer earlier on working at a manufacturing company and then later at a solar company, DIMAIC was a big thing: define, measure, analyze, improve, implement, control. So like that was a big methodology for quality engineering. And I think, yeah, no, it's really cool that you guys have incorporated like the Ishikawa fishbone, which has like origins with Toyota, as well as the FMEA, which has actually origins from the U.S. military. And a lot of that is used by Toyota today. And Ishikawa
mm,
is a great way to look at like the five whys, which I think is also a Toyota thing of like,
Yeah,
why did this happen, right? And then FMEA is like, what could go wrong? And when you put kind
yeah,
of those two things together, you get a really nice contextual picture, like we were talking about, of trying to help AI make sense of how to actually help improve reduction in downtime. But yeah, no, that was great. I was glad you hit on a bunch of the quality engineering stuff there, Harsha. Was there anything you wanted to add to that, Shashank?
all good, all good. I think you covered all.
Okay,
Yeah.
great. Yeah, no, I've had a definitely an early professional interest in a lot of quality engineering stuff, just given a lot of the work I did. So I find that stuff interesting as well. So let's go into the roundtable. I know it's just us here since we don't have Varun today, but just feel free, whoever wants to take it, jump in, and then we can all add context or other interesting things as we see fit. But maybe this isn't like the best question given everything we've talked about being it's the context and how these things work together. But that aside, what is like the one most important signal that manufacturing operations may be undervaluing right now as it relates to what we've been talking about, if you had to pick one?
Interesting. So I would pick, you know, institutionalizing knowledge. I think that sounds very interesting, because if you look at a medium-sized manufacturer, small-sized manufacturer, if the operations are running just because of 2 3 people, I think you need to act. Uh,
Yeah, that's a critical failure point, right? If you only have 2 3 people that knows how to do something or why
yeah,
something could go wrong. Yeah.
yeah. So all the manufacturing, I mean, it's no secret that the manufacturing companies do establish a standard operating procedures to process output. So they take raw material, they establish procedures to create the output. Any fundamental of manufacturing. But what is important is also, are you institutionalizing this knowledge, or is this something that is still living in the heads of the people? The situation is really interesting. So if you look at average age of an engineer in manufacturing companies, 47 years in US. I think in US, in Europe it's even higher. I think like more than 50 years, 52 years like that, right? So unless there is if you have a manufacturing, if you're not institutionalizing knowledge, I think that becomes a really critical signal. So because for these intelligent systems, for the AI wave to when it starts impacting, your competitors are becoming better at producing better products, right, using this intelligence. So unless you institutionalize the knowledge, the AI or the technology that you could bring up later, you would fall behind the race. Yeah, that I think is a single most important thing.
Yeah, no, I think that's really interesting, and I can personally relate to that. So my dad is actually an engineer in a data center responsible for a lot of the different HVAC systems, and he still types kind of with like one finger. at a time, because he's 60, in his 60s. He didn't have computers until much later on. So I think what you're hitting on, especially as it relates to the workforce of the people actually doing this work, having things like we've discussed of being able to record your voice or record a video is very impactful for the types of individuals actually doing this work to actually capture that tribal knowledge in a way that works for them, right? And I think you commented on something interesting as well, the concept of SOPs, right? Like there's the SOP as it's written, and then there's the SOP of like what actually happens, and
It
sometimes
happens.
those don't match. And I think what's also really cool about Dovient is the ability to help you create a SOP based
Right.
on what is actually happening. So maybe doing a little bit of updates to SOPs of how they were written versus how it's actually done live.
Right.
um yeah, no, that was great. I mean, Harsha, what would you pick? What's your one most important signal that may be undervalued today?
No, I think I would also pick knowledge. Yeah. Any other signal is difficult to capture, but knowledge is there, right? It's right there. It's just that you're not capturing it. That's all. Yeah.
Yeah, I think I tend to agree that that's probably the most important. But just to play devil's advocate, I'm gonna throw out another signal here, and just given my personal experience, I'm a huge fan of IoT data. I'm a big fan of telemetry data. I've had the experience of being able to go on solar sites and look at inverters and actually get from the company in Germany that makes these inverters the documentation to tell me all the different Modbus registries I can pull data from, and then being able to put that all in a database and start to look at and do interesting things where maybe it's not even machine learning, but I've been able to do things where if I know an inverter is set up with a certain number of strings on one of its sides versus the other side, and I can compare the current of both of them, it should be proportionally equal to the number of strings in terms of the current. And if that's not the case, I know one of those strings is out or a panel in one of those strings is out. So I think being able to have more data to tie into this context we're talking about with the tribal knowledge kind of completes that picture. So maybe it's not the most important signal, but just wanted to throw out another one that
Yeah.
I think is cool and interesting. All right, cool. Let's go on to the next question here for the roundtable. So where are manufacturing environments still losing planning quality because of the system architecture underneath that just can't keep up with how the operations actually run? And I think we might have touched on this a little bit already, but maybe a good point to reiterate.
Shashank, you want to take it? Or-
Go ahead, Asha.
No, I think you covered it, right? I think Shashank
Yeah,
already covered it
yeah, he already
mainly,
covered it,
right?
but yeah, let's
Yeah,
just
yeah,
double
it's
down on
mostly
it.
like that. I think that, like, and you also said, right, engineering, like quality engineering aspects. So manufacturing is all engineering at the end of the day. You have so many architectures. All of this stays basically on paper, like whether it's your FMEA, whether it's your fish bones, whether it's basically your five eyes, like whatever you do, basically all of this basically stays on paper, right? and and basically if that stays in paper it won't change for years, obviously, because nobody would want to keep looking at it. And obviously and everyone has their own version, like FMEA itself, I'm pretty sure everyone will have their own version of FMEA, because if FMEA says that your machine needs to be maintained every 6 months, someone will come and say that, hey, no, it's not required, I know this, I know better than I know better than the diagram. It's nothing wrong, because they would have seen so much of data, they would have seen so many breakdowns in the system, and basically they know much more than obviously a standard operating manual, right? So uh, yeah, I would say that's where the architecture also a lot of things break. Like I can monitor manufacturing output, for example, like if I have an MES system, an MES system can obviously monitor a manufacturing output. Like you said, if you can bring IoT data, which is definitely important, you can obviously monitor these signals. But ultimately, how does that translate to planning is all basically that's where all of these things come, right? You need these artifacts, and these artifacts need to be properly maintained, digitized, and they need to be kind of like, how do I say? They need to be kind of uh, like for a lack of better term, it should be like an Excel, right? If someone is using, it should be as intuitive as an Excel when you use an artifact, like because uh, they are because that's what people should be were familiar with, and that's how people would start using them better. That's when people will start using them better.
Yeah, and I think Shashank, if you just kind of want to double down on that point you made earlier
Yeah,
about, um, the chaos of the planner calling the shop floor to determine when things are open and when they can do things. I think that also is kind of related to what I was asking, right? Of being a poor system design potentially. So
absolutely.
like, what would be the better design, and does Dovient do that?
Absolutely. So I think, a lot of we, especially since this podcast is about data, I would come it from the data architecture perspective. So a lot of the data architecture, uh, you know, I think one bad data architecture could be something that your company has invested in, and your company might have built a data system, data lake for all the members to use. So, but if only 10% of it people are using, people are not relying on it. So you built a system, you built a nice dashboard to look at all the IoT data alerts. You built a system, but people are not using it. So there is something inherently wrong with the data architecture. So people on the shop floor are very practical, right? So they just see outcomes. So if there is no outcome for whatever system you invested in, for whatever the data architecture you created, if people are not using it, then that's a failure. That's the first point. So how do we avoid it? Is not to give too much information. People already have their own tasks on the shop floor, so they need to go physically inspect systems. They need to go there, see, plan for production, check for quality, and there is already too much going on the shop floor. So but these data systems, whatever, uh, demands either too much knowledge from the actual person sitting on the shop floor. It expects that shop floor knowledge is so intelligent enough to understand some data patterns, data correlations. So they feed too much information to the people, and not to the right people also, right? So giving concise information, limited information, actionable things for a person on the shop floor. So he has to look at the system daily, maybe for 30 minutes, and get whatever he's supposed to very easily. So that is a challenge there. So how do you be lean and give the correct signals to the correct user at the correct point of time, and have an evolving system? I think that will make a good architecture, data architecture.
Yeah, no,
Yeah.
I think you hit on some really interesting things there, and we do talk about process and change improvement as well, not just data on this podcast. And I'm glad you got into that. But yeah, no, I think you hit on some interesting concepts like just in time, right? Like giving them the data when they need it, and then also a phrase that's commonly used in the U.S. government is on a need to know basis, right? So you
Yeah.
give it to them when they need to know it, just in time, and a subset of it where it's not going to overwhelm them or be like, this is too much, right? It's a very specific task driven, like go look at this machine for this, right? It's
Yeah.
and it has the background to be referenceable if you need to do a retrospective afterwards to understand why it may have erred or whatever. But yeah, as it relates to the people taking the action, not overwhelming them like you said with data, I think that's really important. So yeah, I think that kind of relates to the next question I wanted to ask, which is, so like how do we move from, we have this, solid data, good models, helping make scheduling decisions, but then a floor manager in the morning stand up is like, all right, well, I don't trust this. We're just going to do this, right? Like, are there things that are possible with Dovient to help that floor manager kind of overcome that preconceived notion of just like trust or lack of
Yes.
trust in the system? Or is that more of a process improvement or change management that the organization has to take on as they build trust? Maybe you could just comment on what you've seen with Dovient deployments, and how you've convinced these floor managers over time to have confidence in Dovient.
Absolutely, it's a very good question. So I'll take it. So if you look at a shop floor manager, on the daily morning when he visits, so he does two sort of things. One is mundane things. Mundane things is what? he assigns technicians to particular tasks, and there is suppose a decommissioning project or a commissioning project going on. So he has some certain projecty tasks that he needs to assign it to. So that's pretty much straightforward. He identifies the right talent with that core competency, which Dovient has an automated system. So Dovient works with, it doesn't go over the people. I mean, it doesn't jump the gun. So always there is human in the loop. So it recommends all the to-do action items for mundane things straightforward to the manager. So he just needs to spend like 5 minutes or 10 minutes of a day, while he usually takes without Dovient suppose an hour or two, right? So within 5-10 minutes, he just assigns that. That is done, mundane part. Now comes the interesting thing, where there is an element of interpretation, an element of judgment that you need to make a particular thing work. So what we do is we pull from all the knowledge base that is there on the shop floor. So our system intelligently keeps learning on this knowledge, and it gives them recommendations with the correct sources. In this manual, this product manual, for example, this is not a typical problem that you face every day. So there is something going on. So this is how it is recommended for you to solve it, right? We'll give them 2 fixes, and we'll ask the operator. I mean, so again, this is very, very interesting thing. So to win the manager's confidence, we need to win the operators and technicians' confidence also. So if operator and technician gives the feedback to the manager that something is not working, he would naturally believe that it doesn't work. So we'd lose the trust. So we give the fixes that are recommendations and keep learning all the time. So what worked and what did not work. If something did not work, we also take feedback. The Dovient system takes feedback on what worked for them. So that's why it's always evolving, and it always keeps the human in the loop, and it doesn't overdo or over push trying to see something physical. We cannot get more intelligent than physical. That's not possible. So it's always a recommendation in them.
Yeah, no, I think I really liked what you said there in the beginning around helping win the trust of the floor manager by kind of doing that automated work order assignment by availability and competency, and helping them still have that human in the loop judgment call, but essentially presenting it in a way where it's like, yep, those are the work orders. Maybe I move a couple around, but that's good. And now I've moved a 1-2 hour task down to 5 minutes. I think, that inherently will be like, all right, well, it was good at that. Now what else can it do? Right. Like it kind of piques their interest a little bit in starting to build trust. And I like the comment you made as well about not only do you have to have the actual floor manager who's assigning the work orders, but the people who the work orders are assigned to. And that's very important, that the trust is at both of those levels. Harsha, is there anything you want to add to about some of the comments that Shashank made about like that reinforcement learning aspect of, here's the suggestions, tell us what worked and what didn't?
Yeah. Uh, yeah, I think it's just that like basically like on a technical side, there is this concept of federated learning, right? Like learning from hundreds of individuals, thousands of individuals, but removing the like in some way sanitizing that, like not really bringing the exact context, but bringing the learning from the context. So that's what I think was tried in Dovient to basically bring this federated learning concept uh, to basically make the system better over time. And other thing also is basically that you have this like you when you use Claude Cowork, right? Like basically you have this option of asking. So you can basically choose it to ask, or you can basically ask. You can give a full control to it. So you can decide the level of control that you want to give to Dovient. You say that, hey, I don't want to create work orders. You just show me the work orders. I will create it myself. Let's say you just basically switch to an ask mode and say just do that. If you basically say that, hey, I want to actually give full control to Dovient to do things. And again, like not everything, but obviously even some of the things that you're more confident about, you can basically give that. Basically, you can go to an act mode and let it do it for you, right? So there are multiple modes in Dovient. Based on your comfort, you can choose how much control you want to give. So if you are still like not trusting it in the beginning, you can basically just don't give any access, just ask for things and then let it, and uh, basically keep giving. You can give feedback, or you can use it as a knowledge engine maybe, right? But if you are once you start getting confidence, you can basically use you can start giving it more little bit more control.
Yeah, I think that's one of the really interesting things about Dovient you both touched on is like the concept of like getting better over time. The more context you have, the more inputs you have, the more people you have using it, the higher the confidence you have. And then taking things that are lower risk, like assigning the work orders and moving that from an ask mode to an auto mode. And then maybe for even specific types of failures that are well known and have been observed a bunch of times, of being able to say, okay, yeah, this is what we need to go do. I think, yeah, that's a really interesting aspect of Dovian as well. So appreciate you guys commenting on that. So I have one last question, and then we'll kind of wrap up here. I've really enjoyed the conversation today. I think it's been really interesting and sets the stage really well for the next episode we're gonna have. But I guess whoever wants to comment first, but what's one piece of forward-looking advice around where a manufacturing operations team, if they really want to improve planning quality, where should they start? Not like a big digital transformation, just like what's the first real thing they could start doing today with Dovian or not, to start actually making improvements towards quality and operations.
Yeah. So one is, having your plans dynamic, right? So identify some quick wins. You cannot. I don't recommend immediately switching and adopting the best LLM in the market. Do a whole data lake just to get started, then feed all this data lake into LLM and arrive at automated planning. No, I don't start there. So if I have to advise a manufacturing shop floor team, where they can start, so they can identify the the lines, the production lines, or the work areas where the static plans are not working, where they had to change their plans often. So what is it that you're not able to stick to, right? Just take those particular production lines where there is more chaos, and then try to have a dynamic planning system through AI or through a tool like Dovient, so which helps in this FMEA and create plans better, where you can have a measurable KPI, right? Whether it's mean time to repair, mean time between failure, or turnaround time, or TAKT time, tacket time, we call it, right, for production, for producing your items. So pick one KPI and see how you are improving that KPI over the time. So do it on a pilot basis, adapt it, and then you can evolve into a full-blown, dynamic systems with FMEA plans, schedules, and all of that coming into picture.
Yeah, so pick one thing and get really good at it.
Correct. My suggestion is pick the one where static planning is not working, so that you can measure with this intelligent planning, feeding context and also knowledge to the planning. So what kind of planning can you do on the shop floor? So once those things are there, you will have a KPI attached to it where you can measure and take a decision
Awesome.
for going into the next step. Yeah.
Harsha, what's the one thing you'd recommend people do to get started?
No, I think Shashank mostly covered it. I think it's just that you like most of it is reactive, right? Like let's say even at least in the mid-size manufacturing firms, most of planning is reactive planning. At least if they move to preventive from reactive, you don't need to be predictive from day one, but at least like move to preventive planning where you have a way of where you know like when to maintain, how to maintain, and things like that. And you also don't do a lot of over maintenance or under maintenance. I think that's I yeah, because like a lot of machines today, a lot of machines are still run to fail machines. Like they just let it fail, right? So when it fails, they basically say I will do the maintenance today, but it will cause a lot of issues in terms of the throughput in the process of failure, right? So just identifying that and being smart about it itself is, I think, is a big win.
Yeah, I think
The
again, I mean, just to want to correct and confirm to the audience. So we are a bit lean towards maintenance, but on the production planning also, with the same applies. We have signals coming from other, you know, what do you call, other systems or other data points, right? We have a supplier data point where for which supplier may not have sent the raw material to you yet, so you cannot plan it now, so you have to postpone the plan. So all this, the same principles apply, using this agent architecture. So we can also, in the Dovient platform, so there is an option to build custom agents for your custom industry, right? So where you have a specific problem, so to adapt, to react to such signals for better planning on the shop floor. So that is also possible. It's not just maintenance, but production also falls under, a um, similar problem and similar solution. Yeah.
Yeah, I think that's a great point and a great way to end it, because I think those things are very interrelated, right? Like
Yeah.
the planning has a big impact on the shop floor of when the machines are running, when they're available, and then
Right.
things like you're describing with suppliers, that gets exacerbated when we have supplier crises like COVID or Strait of Hormuz being closed, where the materials you're sourcing are coming from these areas where now they're constrained, and now you're doing a lot of different things that maybe you normally wouldn't as it relates to the shop floor because of those constraints from planning that roll into the actual production and what you're producing. So yeah, this has been a really interesting conversation today. I think we just set the new record for the AI After Hours' is longest podcast with just the
Oh,
three of us here today. So this was a lot of fun. I really appreciated the beginning, Shashank, where you kind of outlined the before and after AI in manufacturing. Harsha, thank you for diving deeper into some of the signals, the agents. You both touched on really well this concept of transferring tribal knowledge out of the heads of the people you have working, helping digitize that, how it makes things better because it gives you more context. The quality engineering conversation was great, and then yeah, this where to get started, I think, was a good idea of how to maybe help people come up with what a pilot should look like if they want to start going down the path of doing some of these things. And then tying this all back to planning at the end here, I think kind of helped highlight the big picture. So thank you both. This has been a great episode 4, manufacturing with Dovient. Episode 5, maybe 2 weeks from now, I think, is when we'll try to record it. That one's going to be all about optimizing production and inventory as it relates to some of the things we discussed today. So capacity decisions, lead time management, inventory positioning, the different trade-offs, how improvements in operations can impact these things, and what Dovient can provide around that. So just thank you again, both. This has been a great discussion and a great episode in my mind. Is there any closing remarks or closing thoughts you want to share before we end it here today?
that's a great. So I'd like to thank AZTRA for this opportunity, and it has been a great conversation, Shan. I think you really managed it well. So the only closing conversation is, this is such a vast topic. So there are few chances that we might go over all the places, because manufacturing is very vast in itself. So you have different types of manufacturing, different types of problems on the shop floor. Each shop floor is very unique. Each, I mean, so between plants also there is a lot of variance for within one organization. So it's very, but glad that at least we are able to be on the topic. And for all the viewers also, I'd like to thank a lot for your time. Thank you.
Yeah, that was great. Yeah, I guess if anyone wants to hear some specifics to uh, a type of manufacturing organization or something like that, if you want to leave a comment, we can definitely uh, double tap into that on our next episode and give a more specific lens as opposed to a general one. But yeah, thank you as well, Shashank, for being here. This has been great. We really enjoy working with Dovient, and I think this partnership's a really fruitful one and will last a long time. So look forward to having you back in a couple weeks. And thank you, Harsha, as always for being on and having a lot of fun with the season so far of this podcast. So thank you everyone for tuning in. We'll see you next time. This has been
Thanks.
AZTRA
Thanks, everyone.
AI After Hours. Take care. Bye.
Thanks. Bye.
Bye.